welcome to Reline Live. Thank you guys so much for joining. We're going to get started right on time today because we do actually have a lot to cover. This was a really cool project. I have Steve Burks, who is the Director of Operations for CPM Pipelines with me today. Thanks, Steve, for joining. He was on site with Michael and I at this install. Michael is a pipe reline specialist that works for my company, Reline Solutions. He's based out of Denver, Colorado. I'm based in Boise, Idaho. That's a little background on us. Housekeeping. I am recording this, so if you guys miss anything, it will be recorded. Bailey is our marketing coordinator. She will have it on our YouTube channel before the end of the day, and we can always send that link out as well. We like to make Reline Live very interactive, so use the Q&A box below. I'm kind of more of a moderator. I will be jumping in and asking questions as you guys are asking them in real time. So if we go a little bit over, that can happen if we are getting a lot more questions than we predicted. So please feel free to be interactive with us, and we don't like to just sit and talk at you. So a little background on this pipe project. This was something I was brought in on less than a year ago with InstaPipe. They're based in Washington, and this was a 12-inch pipe that was put in the ground, and it was intended to be used, and then anyway, things happen. It never actually went into service, but then fast forward, and now there are new facilities going in there, specifically a very large Amazon facility right off the I-5 corridor, and they want to put that pipe back in service. So they went to test the pipe, and the pipe didn't meet the pressure test. Steve can probably go into a little bit more of that, but that is where we got involved, and that's kind of where they were looking for solutions rather than digging and replacing 1,200 feet of this pipeline because it sits right next to a railroad track and right off the freeway. They wanted to look at rehabilitation rather than rip and replace. So with that said, I am going to pass it off to Steve. He's going to talk about some of the considerations that we had to take into rehabbing, and then he's going to jump into the installation methods and what kind of happened on site.
All right, how's it going? As you can see, actually this photo here, this was the second day. I showed up a little bit earlier and I was lucky to see the sun of Washington. And then this came around for the rest of the day that I was out there. But, kind of hitting on the considerations, anytime we're doing any type of pipeline replacement or rehabilitation project, there's a number of considerations we want to keep in mind. And this one had a number of very unique considerations. We were really close to a waterway that is just, I think this photo is taken probably over the waterway. So we had a waterway that we were really close to. We also had two major intersections. There was a highway on-off ramp that we were pretty much starting and ending at. So we had some heavy traffic areas that we had to kind of operate around and throughout. And then we also had some railways that was right there as well. So, when we're talking about how we're going to replace this line, traffic control and time that this is going to be down is definitely something that we want to kind of focus on and talk about. We were in an instance where we were still in the roadway. We still had to have traffic control. We actually were in an instance where we needed 24-hour traffic control because we had a lane closure down for those two pit locations. So these are all things that you want to kind of talk about and think about because that's going to determine if we're out there for 2 days on a rehab project, or if we're out there for 2 months on a replacement project. Do we have traffic control 48 hours for 2 months, or do we have traffic control for 24 hours for 2 days? Those are all things that really, I think, played major factors into the considerations of this project.
And Steve, before we get into any questions that Cassie may have or your next point, I'm trying to move along with you in the pictures. So just let me know if you want to pull up something specific, and I'll get it pulled up.
Okay, perfect. Do you have an aerial, like a full aerial of where we were to kind of?
Yes, I was just looking for that with something like this.
Yeah, man, that's a really good one. So we were lucky enough to be able to place this first entry pit inside of a private property bounds. So as you can see right in front of us, this is the off ramp coming off of, I think on and off on both sides. So we have an entry and exit right here that you see right in front of our first pit. What you don't see from this photo though is the bridge that you see in the top of that photo. A little bit beyond that, there's an additional pit that's on that side. And right where that pit is, there's another entry and exit of that freeway. So as you can imagine, this pipeline's running pretty much in that lane where the cars are coming towards us. So if we were going to dig and replace, we'd have that entire section, 1,200 feet, dug up for an unknown amount of time. So I think that kind of rounds out, I think, why we chose or why the decision was to rehabilitate on this. Are there any questions that have come up regarding that spot yet on why we chose rehabilitation?
Yes, anything yet? Nope. Good to go.
No questions. Sorry, I was muted.
You're good. What I'm going to do is I'm going to kind of switch and kind of push over towards the installation process and kind of what we did out there. The pipe here was pretty shallow. I think it was about 4 or 5 feet under bury. So our pits were pretty minimal. Typically, our pit sizes are anywhere between a 6x6 dimension pit times the depth, 6x8, depending on if we're doing tiebacks on the other side or we're just rehabilitating that line. This one, we had one side where we were leaving a fitting and they were going to tie back in. The other side, we tied back into their system for them.
So Steve, real quick, I do have a question. So this access pit that we're looking at in Michael's photo right now, just because point of reference, it's hard to tell visually, how big is that access pit?
So this photo here's kind of the shoring box that you see in this photo is not where we're actively working. So you'll see the group of people kind of in the middle of that photo. That is the access pit. So this one was actually a sloped access. It's sloped on the where the trailer is and where the reel is. It's sloped down there, probably about 15, 20 feet long worth of slope, but really gradual. We had a ton of room to play with on that side. So they really just sloped it out to give us a ton of room for pulling in the equipment, things like that. And I think this pit here, between side to side, is maybe about 8 to 10 feet. Again, this is a lot larger than what we would typically do because we had the room to play with. I'm sure there's some photos of the other pit. That one is a lot more realistic. That one is about the size of that shoring box that we put on that other side. So traditionally, we like to give ourselves about a foot of clearance underneath the pipe and about 2 feet of clearance on either side of the pipe. But with that being said, that can't always happen. As long as we have some clearance underneath to be able to get the tools, we can kind of be flexible with that. I might have. So, on this job, this one here, this one's a very tight pit. So typical to the job, things change while we're out there. So we actually showed up on this job. The pits were already dug. The pipe was already exposed. And we arrived ready to start camera cleaning and start the Reline project. This pit here, though, was in the lane. And with the amount of area that we had to dig out, it made it really difficult to plate this overnight. And we had one night, we came in late in the afternoon to start the project. We stayed overnight one night and came back the next morning to finish the project. So we needed to be able to protect this overnight. So what we did is we actually ended up having to backfill the left-hand side of this box where those guys are standing there to allow shoring plates to be able to put on there. And just speaking of tradition of construction, things change. We were able to adapt to it and be able to fit into those small spots. And that was a little bit tighter than we like to work with, but it is what it is. We were able to make it work. Typically, we like to keep ourselves about 5 feet of room between the hose pipe and hose pipe that we cut out, and that's for the hydraulic pressing. So as long as we have that room, we can still get our press in there, we can close that.
One question for you, Steve, and I mean, I was on site, so I know the answer, but from beginning to end with the pipe cleaning, which wasn't really necessary because this pipe had never been put into service, what was our timeline, basically, like our full timeline? Because Michael and I were both just on site, even shocked how fast. I mean, we got to fly home early.
Yeah, there were a lot of things that were done already. There wasn't cleaning. Cleaning can add a lot of time, and this one didn't need the cleaning. So with that being said, timed everything. We had 9.5 hours worth of work, like active working hours. So that
Yeah.
means from, we showed up on the job site. It took about an hour to camera the line because we had to camera the line from both sides. Being 1,200 feet, we didn't quite have enough tether to get all the way across. So we camera from both sides. Once we got done cammering, we had a vac truck sitting there on standby. So we, on the side where the liner is, so this side right here, we had a parachute. We dangled a parachute and we actually sent the jetter nozzle in about 50 feet from the far side. And what that did is that created a vacuum in the line and allowed that to pull that parachute out. So tagline took about 20 minutes to get that through. It took about 20 to 30 minutes to get the winch cable pulled through and connected to the liner. While that's happening, the liner's being set, the winch is being staged, the rollers are being put. You see a roller on the front of the pipe on that photo right there, and that's actually the tagline getting sucked into the pipe. So you
Yeah,
can
sorry, Steve, I was pausing for a second to try and get to the video while you were explaining it.
Yeah, it goes fast. I mean, I've gotten 1,700 feet in under a minute with this setup, doing it similar to this. So get moving tagline. Typically a challenging thing on this job. It went pretty smooth for us. Once we got the winch cable through, though, that it's really time to start going. The pulling head was put onto the liner already, and you can see it there. It's attached to a cable. And we just start pulling. The winch pulls, we typically pull between 25 and 35 feet per minute. On straighter shots, we pull even faster. I think this one we pulled at 35 feet a minute, and it took us like 36 minutes to pull this liner in. The liner is folded and flat when it's pulled into the pipe. So we have to inflate it, and that actually does two things for us. So the liner's been pulled in. We put the inflation fittings on, and we start inflating that liner, and that's doing two things for us. One, it's opening that liner for us. That way we can verify that it's popped open, it's not twisted inside of there. It's actually fully open to the inside of that hose pipe. But what that also does for us, it does the second thing, is it gives us a verification that that liner wasn't damaged going in. Because we're building compressive pressure inside of that pipe to pop it open, we have to be able to compress that pressure. We have to have a closed system to be able to build that pressure and increase it to pop that tape. So what we do is we have a predetermined set pressure, and I think this pressure on this liner was 9 psi. So we pumped it up to 9 psi. It took about 46 minutes to inflate that to 9 psi. And then we turn the whole system off. We turn the compressor off, we turn the gauges off, we turn everything off, and we let it hold for 15 minutes. And we don't want to see a drop on that. And that's really giving us a great final verification that that liner was installed properly. It's holding air. There's nothing that's leaking out of that pipe.
Was there anything done in advance to make sure that that liner wouldn't get damaged once it was pulled through?
Yeah, so there's a huge emphasis on the CCTV portion on the front of this. So rewind even further than that. Every liner coming from the factory is hydrostatically tested at 1.5 times the operating pressure for 24 hours. So this individual piece of pipe, I think it was 1,225 feet or something like that. That was hydrostatically tested for 24 hours at 1.5 times operating pressure before it even came to us. Once it came to us, we do a CCTV inspection to verify that nothing in that pipe is in a position that can damage that. We're looking for sharp objects inside of that. We're looking for large holes with debris falling into the pipe that could come in and collapse onto the pipe. We're looking for anything that can cause some issues. And typically it's fittings. Typically it's install issues of fittings or valves when they're heavy corrosion around it or they're kicked a little funky. But there's a big emphasis on that because we want to make sure that that's not damaged. And there's a big warranty that's provided with that. Go ahead, Michael.
And Steve, it looks like you're starting to get close to the answer to this question, but just had one come in about what happens if the existing pipe has infiltration. You want to touch on that?
Yeah, so that's a really good question because it depends on the amount and where it is. So I had a pipeline that I did a couple of months ago that we had a decent amount of infiltration. in 3 locations. Two of those locations were large holes, active holes in the pipe. They were about the size of a softball. And when we were able to see those holes from the CCTV footage, we saw rocks getting blown into the pipe. We saw debris getting flushed in. For us, the bigger problem there is the debris that's getting pushed into the pipe that's now becoming an abrasive zone between the tight fit liner that's being pushed against the hose pipe. So water being inside the hose, between the hose pipe and the liner, isn't an issue, because once that system goes under operational pressure, it's going to displace that water out. Now, what we don't want is we don't want debris coming into there. So in that install where I had those 3, 2 of them were large enough spots and in bedding pockets to where the debris was getting flushed into the pipe heavily. So what we did is we put internal joint repairs in there. We were able to robotically install those. We were able to ship them out in a day, have them robotically installed, and be ready to pull the liner later that day on those 2. And then on the one, we determined that there wasn't debris coming in. It was a type of hole that really wasn't getting debris. The debris pocket was far enough away that we weren't getting issues inside that pipe. So we determined that we didn't have to block that. So it'll situationally change a little bit, but typically we say a baseball size or larger, we want to cover up.
Thank you.
I think to this point where I've talked through is liners, inflation fittings have been put on. We start inflating the liner. We stopped inflation for the install hold test. And that's really one of the second to last QC that's done to verify that the liner's been holed, it's been installed, it's been inflated all the way, and it's not leaking. The last thing we got to do here is we got to put the fittings on. So there's a little bit that has to be done. We typically trim the liner back to pretty much flush with the fitting. And the fitting's a 2-part fitting. There's the outer flange tube that's already on the pipe that we pull the liner through. And there's another piece, the inner flange tube, inner pushing tube, that we're actually going to install. We're going to trim the liner back, open it up, and install that inside of it. And it acts similar to like a copper compression fitting. So on the outer pushing tube or outer flange tube, there's ribs, and the inner pushing tube smooth, and we're actually displacing the liner into those ribs, and that's locking that down in place. Once we get that there, we hydraulically press it. So that's there doing the air test still on that.
I can probably fast forward to the pictures with more of the fittings. Here we go.
Yeah, so that's them lowering. There's a second piece. So the piece on the right there, you see double flanges. That's the outer pushing tube, or sorry, that's the outer flange tube. That's where the ribs are. The ribs are on the inside of that pipe, and that's what we're going to displace that liner into. They're lowering there the hydraulic press, and you can see it's a heavier piece of unit, or a heavier unit. We have equipment on site to help us lower that down. There's actually all threads. So what we're doing here is we're locking in that fitting into a contained zone, and we're compressing that fitting within that zone. So we're putting a hydraulic press on there, locking it in with all threads and nuts on both sides, and then expanding that press to press the fittings together. This is wrapping up towards the end of the project. So we had talked a little bit about pressure testing on the pipe. We hydrostatically test it from the factory. We do a air pressure test in the field during installation. And 99.9% of the time, that's more than sufficient. Air is going to escape faster than water. It's going to escape in smaller crevices than water. And a lot of times, that's enough for us to say, and us to provide the warranty that that liner was installed properly. Depending on what the client wants to do, some clients want to do a hydrostatic test. We kind of push that off and say, if you want to do it, that's fine. I have no problem with you doing a hydrostatic test. I'll help you with it. That's fine. And that's what we did here. So what they're doing here is they're installing some hydrostatic testing setup. So they have a blind flange with the outlet port on one side, and this one here's the fill side. So they're actually, it looks like they have it reversed. I think they did on that for the beginning, but filling the lineup for the hydrostatic, and then chlorination as well. So with that being, go ahead.
Steve, do you recommend a pressure test, or is this just totally job dependent, client dependent? Like, is there a situation where you would say we should always pressure test versus like maybe a smaller pipe or a smaller run where you're like, it's really just an engineer's decision or the city's decision?
I would say it's an engineer and city decision. I mean, I've had jobs that have gone both ways, that it's been in the spec that they want a hydrostatic. We give them all the testing results of what we've provided so far. And they say, oh, that's fine. And then in the same breath, I've been in it to where they say, yeah, I know, but we're still going to do this. So it really, and I mean, it even goes as far as the bolts and nuts that we use. It's same thing with that, right? If there's a spec for the bolts and nuts, we can change that to match the spec.
Right.
We're obviously going to try to do things that accommodate the system already, rather than trying to throw something completely new at them. So
Yeah, I'm just gonna try and pull up some more aerial footage while you're kind of talking. I know that there was another question, and this was something that I think Michael had run across. With it being a class 3 system, structurally, is there a way to provide a class 4 structural? And Michael, maybe you can elaborate on that question that you received from a potential customer.
Yeah, so I just got that question actually a few weeks ago from somebody in Utah. I'll leave the elaborating for Steve if I don't answer it fully, but I was told that we could, it's on rare occasions where this would be necessary, but we can install a very thin CIPP structural solution so we can meet the class 4 rating there. And then we could pull the close fit BulletLiner system through that CIPP. So we beat both the class 4 as far as structural goes and for the pressure rating.
yeah, and that's, you hit on a really good point. I think that there's no one solution that's a solution for everything. And I think that anybody that'll say that it is a solution for everything, I don't think they realistically know what they're talking about. But there's a great combination of solutions that can be solutions for a lot of things. And Michael, you brought up a great point there. In situations where maybe you have some collapsing pipe, you have some real bad erosion that's happened, you've had, the bottom of the pipe that's been taken out. There are instances where we do run a very thin CIPP class 4 liner inside of that. Traditionally, I see those in small segments. So if we have like here's, a 500-foot segment that we're lining, or even a 5,000-foot segment that we're lining, but here's 200 feet in the middle that's a straight shot in between where the pipe's starting to collapse in the middle. Let's get that. Or here's 5 feet here. The kind of the issue that runs in when we start looking at like CIPP is going to be bends, right? CIPP doesn't like bends, especially when we're talking about structure. But again, there's a lot of straight segments. So to say that it's a solution to just say, hey, I need to provide a class 4, I know we can do this. There's a possibility we can do this for sure and provide that solution. But that just goes to the point of, there's options out there. We need to increase pressure rating. We can actually combine some pressure ratings with the hose pipe if the hose pipe's in good condition, because we are a tight fit, right? We're pushing out to a liner. So we actually have some combination structure or combination pressures that we can add to that as well. So we have some options. It is a engineer design solution. So, for instances where it's a higher pressure situation, we can change the warp and the weft of the liner of the weave to add additional pressure ratings on that. If there's different medias on the inside, whether it's slurry piles or wood chips that we're trying to send through, we can change the molecular makeup of the inside and the external jackets, whether it's making it more malleable, making it more chemical resistant, heat resistant, durable. It's not just a one size fits all. What we're talking about here is the water, which happens to be, kind of catered towards chlorine residuals and things like that. But, we have options. We can definitely play around with it. We have a lot of customization with it as well.
I will let Michael, you've got a ton of questions coming.
Yes.
If you want to field those.
He said something that got the ball rolling, but
Yeah.
let's start with, since you were starting to touch on it with the customization aspect, the make of the liner as well as where it is manufactured.
Like the makeup component, so it's a modified polyethylene inside and outside jacket, and it's a polyester warp and weft, so a weave. We can modify that warp and weft. Again, all of those are modifiable. So depending on what we're putting through it, we'll change the inside and outside jackets, depending on the pressure ratings and tensile strength, or if we're using, if for oil and gas, we'll add copper or Kevlar aramid to the weave. So that's kind of where we'll change there. And it's manufactured in Taizhou.
And we'll start with I believe the simpler question. So is there any pipe material where this liner cannot be used?
Not that I haven't ever come across something where I come with a material and they say, no, we can't do that. I would say it's sizing, right? If really think of a pipe as a tunnel that's within a size range, and I can put a liner inside of that tunnel with between 2 and 48 inches.
Can you pull this liner through bends? Yes. Steve, would you mind sharing some of the limitations or what we'd be looking for if there were multiple bends?
Yeah, so typically with bends, we like to limit ourselves to 45s. We don't like going beyond 45s. So 45 stacked 45s, not a problem. We like to limit ourselves at about 10 of those 45s in a alignment. Obviously, that'll change a little bit if they're going against each other, back and forth a bunch. It's adding additional force to that. But that again goes to the design of the installation, right? Where are we installing from? Are we putting all those bins on the front of the system, or are we putting all those bins on the back of the system? Is the entire liner feeling the force of that pull, or is it just the end feeling the force of that pull? So we pull through up to 45-degree bends and sweeping bends and segments as long as we can get. So really our segment lengths, we can get 10,000 feet of liner on a spool. So the question is, can you get 10,000 feet of cable to pull? So.
Perfect. With delays and other pipe materials, what is the lead time currently estimated for manufacturing and shipping to get this pipe on site?
Manufacturing's typically, I think it's 14 to 21 days if it's not already made. If it's not just sitting on the ground. Size and length is going to determine shipping. If we can put it on a plane and put it on a plane and air freight it in, we're looking about 5 weeks from order in to order out. So manufacturing, getting it shipped, getting it through. If it is going on a Connex and getting boated over, again, we have the ability to speed up the boats, do fast boats or slow boats. But that ranges between 8 to 14 weeks, just depending on what boat rate we're taking and the urgency of it.
And last one from this rapid fire Q&A portion of this webinar. In terms of design, what is the difference between BulletLiner, and this part where that confused me, compared to other FFRP products that claim to be a fully structural solution class 4? I didn't know that other FFRP liners claim to be class 4, but
yeah, can you ask that question one more time?
So yeah, let's just keep it at, what is the difference between BulletLiner compared to other FFRP that's out there?
So the biggest difference between BulletLiner and other FFRP systems on the market today is going to be tight fit versus closed, or tight fit versus loose fit liner. BulletLiner is designed to be pushing tight up against the inside of that hose pipe. We're trying to mitigate the highest amount of annular space. We also are aware that traditionally pipeline designers and engineers don't like annular space because of the possibility of gases and things like that can get inside of that. So really, we're on the side that we don't want annular space. So that, I would say, that's probably the biggest difference today, is the annular space, and then the fittings is going to be so different from any manufacturer. So how are you putting that fitting back together? How are you tying that back into your system?
Yeah, and really across all trenchless technologies for any application, there's never been annular space really recommended for any solution ever. It's been either you grout it or you have a tight fit system. So just because of all the damage that can be done if you continue to allow infiltration through that hose pipe. So that doesn't answer your question, feel free to ask a follow-up one. But last question, what if there are service taps on the line?
So if somebody on this call finds out a way to tap my liner, you'll become a millionaire. Right now we don't have a way to tap the liner. So this is more for your transition, or sorry, yeah, your transmission or your force mains. I have done installs in neighborhoods that are kind of more spread out in the neighborhood taps, where they're about 300 feet apart, and where we've done like spool banks to put the services into. But no, we don't tap on our system. We don't have any way to secure and boot it to the outside. So it's just going to be in between those service taps.
All right. Well, I'm not
Awesome.
sure where we left off, but that answers the questions in the queue.
Yeah. We are right at 10 a.m. So I don't know if what more you want to cover on this, Steve. I just keep kind of looping through more videos that we have on site. But if you kind of want to wrap up, we always obviously can answer follow-up emails and questions that way. But we'll also send kind of a recap on this. And once it's on YouTube, I can send everyone the link.
Yeah, no, I think this was as textbook as it can go on a job. I mean, this was we were there for less than 24 hours working. System was the pressure test and chlorination took honestly longer than any other phase of the project. So at the end of the day, it really was a perfect situation underneath roadways, right next to railways. I mean, this is where we want to be doing slip lining. So
Yeah.
yeah, it was a great install. Great.
And
Great.
Michael did a great job with all of his drone footage while we were there. I've been showing it so you can get a full 360 picture of our project. So if there are no more questions, thank you guys so much. This has been a really great Reline Live and very interactive. We always appreciate that with you guys. It's such a great group to work with because it's fun to get you guys involved and ask questions in real time. Oh wait, we might have one more that just came in. Oh, nope, just thanks for sharing. You're welcome. Thank you guys so much. Thanks, Steve. I know you did a lot of work getting this ready and kind of typing out all of your notes, so we appreciate it. We had a lot of fun being on site with you for this one.
Of course, looking for the next one.
Yep, absolutely. All right, thanks, guys.